This video picks up from where we left off in the video for the long run as well as the short run total cost curves. So today we're going to talk about the average cost as well as the marginal cost curves. Now this video is extremely important because it's going to determine how well you do for chapter 4, which is the chapter on market structures. So you have to pay attention to this video. There won't be much joking around because this is a very key topic. So what are these curves? Okay, we're going to start one by one. Let's talk about the average cost curve first, shall we? Judging from its name, it's easy to see that the average cost is equals to the total cost divided by the total quantity of X produced. It is also equals to the average variable cost plus the average fixed cost. Now, the marginal cost tends to be a little bit more complicating, but it's actually pretty easy. It is the change in the total cost divided by the change in the quantity of X produced. Okay, so in English, this means that the marginal cost is the additional cost that is incurred by the company for producing an additional unit of X. Okay, so that's what it means in English. That is simply my way of translating the math into something that's more understandable. So let's use an example to understand what is average cost and marginal cost. All right, let's use a numerical example. So let's assume that the fixed cost a company faces is going to be 10. Okay, so we're going to analyze the amount of units produced, what's the total cost for producing that much units, what's the average cost and marginal cost for producing that particular number of units. So let's say we have a 0, and of course when you produce 0 units, whether you produce or not, you're going to be facing a fixed cost of 10, so that's a fact. The fixed cost has already been incurred when you started the company. So let's imagine that when you produce 1 unit, it's going to cost 18, when you produce 2, it's going to cost 23, so on and so forth until 4 units. So there's going to be no average cost when you produce 0 units, because to find the average cost, you need to take 10 divided by 0. Well, you can't take 10 divided by 0 because that's going to give you a number that's infinity. So we're just going to ignore that for the moment. So what I'm going to do now is to fill up the rest of the average cost column by taking the total cost divided by the number of units produced. So we've got these following numbers over here. As you can see, it's very straightforward to calculate the average cost. You simply take the total cost divided by the total number of units that's produced. Now let's move on to the marginal cost. The definition of the marginal cost is, again, the additional cost incurred for producing an additional unit of X. So to increase my amount of X from 0 to 1, I'm going to have incur an additional 8. Okay, so the marginal cost for that is going to be 8. So I'm going to do the same thing for the rest of the other units. You can notice that the marginal cost is simply how much the total cost has increased for increasing 1 unit of X. So you see, on this column, on the total cost column, you're going to see the change in total cost. And you're going to see on the units column, the change in X. Well, the change in X is, well, just 1, because you're increasing by 1 unit, by 1 unit, by 1 unit. And basically, you take the difference between the total cost for one increment, and you divide it by 1. So that is how you actually fill up the column for marginal cost. Now let's move on to the more important question. Why do we need to find out what is the average cost and the marginal cost that a firm faces? Well, the first reason is because of profit maximization. Now let me introduce to you the profit function. Now it is very obvious that profit is equals to total revenue minus your total cost. The residual of that is obviously your profit, right? So how do I maximize this? I'm going to differentiate the profit with respect to X and equate that to 0, because this is how we maximize functions, right? This is basic math. So I'm going to get MR minus MC. What is MR? MR is my marginal revenue minus my marginal cost. So why is it that I get marginal revenue and marginal cost after differentiating total cost and total revenue? Well, that's because in differentiation, what you're doing is you're actually trying to find out the rate of change, right? So when you differentiate something, you're finding out how much it changes. So this is also known as the marginal change. That is why when you differentiate something that's a total, you get the marginal, all right? So I'm going to rearrange that equation, and I'm going to get MR equals to MC. And this is simply the profit maximization rule. And for firms to follow this rule to maximize the profit, what they simply have to do is to choose the quantity of X to produce that fits this equation. So it's actually very simple. Let me use a mathematical example to explain why this is the case. So profit is equals to your total revenue minus your total cost. From this equation over here, I think it's easy to see that P times X is going to be your revenue, because that's the price multiplied by the amount that you sell, and your cost is going to be C times X, which is actually your variable cost multiplied by the quantity that you produce, and of course you're going to deduct your fixed cost. And to find out how much the market price is, we simply look at the demand curve, right? So this is demand function. Let's assume that it is 20 minus x. So 20 minus x over here is a demand function, and of course, as x increases, the price is going to decrease because of the negative sign in front of x. So we're also going to assume that variable cost is going to be 5, and the fixed cost again is 10. So the next steps will be to maximize this function with respect to x, because I want to know how many x I should produce to maximize my profit. So I'm going to do the differentiation, and then I'm going to start solving for x. And you're going to realize that x equals to 7.5. So what it means is that for the firm to maximize its profit, it simply has to produce 7.5 units of x, and that will help the firm to maximize its profit. So that is a very simple reason why we need to know what is the marginal cost. Okay, now I just want to touch on the marginal revenue for a little while. Now, marginal revenue can also be simply just price, and it can be a fixed figure. But we're going to go through that in the next topic, because this depends on the market structure that the firm is in. And well, that's going to be in the next chapter, so stay tuned for that. And the second reason why we're going through all this pain is because we want to talk about profits, right? So you want to know whether profit is going to be more than 0, less than 0, or equals to 0, given that amount of x they are producing. Well, you might be maximizing your profit, but you might not be making positive profits. You might be minimizing your losses. Okay, so that is the second reason why. Now, to talk about profit, we need to take revenue versus your cost. And to make things simpler, let's talk about average revenue and average cost. So obviously your average revenue is going to be a price. Well, that makes sense, because if you were to sell 10 pieces of X for $5, your total revenue is 50. You take 50 divided by 10, that's 5, right? So the price is also the average revenue, okay? So it is also easy to see that when your price is more than your average cost, then you have positive profits. Well, but if your price is equal to the average cost, then your profit is equal to 0, all right? You're covering just about everything. When your price is less than your average cost, then you have got negative profits, all right? Your revenue is coming in, is not enough to cover your cost. So that's why you're making a loss. But does it mean that a firm has to shut down its operations in the short run? Well, the answer is no. It does not have to, okay? And it just doesn't make sense to give up, right? You have to persevere. You have to keep working hard until the business breaks through. All right. So yeah, that's supposed to be muscle. In my drawing isn't that good. But well, that's not exactly the reason. Having perseverance is not the reason why you shouldn't shut down. Okay. The real reason why you shouldn't shut down is because if your price is going to be more than your average variable cost, you should still continue your business. Now let's look at a numerical example to explain why this is the case. So if your fixed cost is going to be $1,000, the price is $10, the average variable cost is $8, and you're going to be producing 10 units of X. Now the average cost is going to be calculated as such. You're going to take the total fixed cost, and then you're going to add in the total variable cost, which is 8 multiplied by 10. You take this figure divided by 10, you have an average cost of, I think it's, let's see, $108, okay? The price is way lower than the average cost, but the firm shouldn't shut down as yet. Now look at this. Since the price minus the average variable cost is going to be 10 minus 8, which is 2, this $2 could actually cover the firm's fixed cost of $1,000 in the long run, right? Because that $2 can slowly cover up the fixed cost of $1,000 as it produces more quantities of X. Then that is assuming that the fixed cost doesn't change, it doesn't increase, the firm doesn't incur any more of this capital expenditure. Okay, so as you can see, the average cost of $108 is more than 10, but it doesn't mean that the firm should shut down. I'm not going to offer you another way of seeing this. I'm going to be introducing to you a concept called decision tree making. Alright, so let's check out this firm. Okay, the firm has got two options. Okay, it can either shut down its business and in that case producing 0x, or it can just simply continue its business and produce up to 10x. Now the truth is, whether he chooses to shut down or continue, he's going to incur a loss of $1,000. Okay, so if let's say he chooses to shut down, he's going to incur that $1,000 loss and he's going to make 0 revenue. So his overall outcome is going to be losing $1,000. But if he chooses to continue and produce up to 10 units of X, he still has a chance of earning the margin of $2 per product. So he's going to end up with only a loss of $980. So if you're the firm, which are you going to choose? I hope you're going to choose to continue, because if you continue, you're going to be less miserable as compared to shutting down. You have somewhat minimized your losses. So a rational firm is going to choose to continue instead of shut down. So that is the reason why when your price is still more than your average variable cost, you should still continue. Okay, so much for that long story. Well, this is a very simple explanation to why you need to know what is the average cost of a company. Okay, now we're going to go on to the most exciting part and also the most important part of this video. We're going to talk about how we can derive the average cost as well as the marginal cost curves. So how do we do this? I'm going to talk about a little bit from the last chapter. We're going to need the ISO cost and the ISO quant. Okay, you know that ISO cost and the ISO quant is going to give you your total cost curves. Okay, if you don't recall this, please watch the ISO cost, ISO quant video as well as the total cost curve videos. So from the total cost curves, you can actually derive your average cost and your marginal cost curves for both the long run as well as the short run. Okay, now the next thing that I need to go through with you is what are the basics of deriving these two curves. Let's talk about the average cost curve first. We know that to calculate the average cost, you need to take the total cost divided by the total quantity of X. Okay, and you're going to need the total cost curve. I'm now going to very quickly draw a short run total cost for the purpose of our demonstration. Now you're trying to find the average cost for different levels of production. So you're trying to find the average cost for X0, X1, and X2. What are the average cost for X0, X1, and X2? So that's the question that you're answering. To find that out, simply, let's take a look at X0 first. To produce X0, the total cost incurred is going to be TC0. So you need to take this width divided by this height to get the total cost, to get the average cost, because average cost is TC divided by X, right? So that's average cost naught. AC naught is going to be the first average cost. Now for X1, the total cost is going to be here. That's TC1. So you need to take this width divided by this height, and you're going to get AC1. Okay? Now for X2, to produce up to X2, the firm is going to incur a total cost which is shown by here. Okay, so that's TC2. So you take this width divided by this height, you're going to get AC2. So congratulations, you have found all the average cost curves. So that was pretty easy, right? But here's one issue. So things that you've got AC0, AC1, and AC2, which one is bigger or smaller? You have got no idea how to find out. So you don't know the answer. So how do you do this? How do you determine the relative size of each average cost? Well, the solution is actually pretty simple. You're going to have to draw rays from the origin of this graph to the total cost curve itself. So just let me prove my case to you. I'm going to start drawing rays for X0, X1, and X2. Okay, so that's a ray for X0, and this is a ray for X1, and lastly, this is a ray for X2. So from now on, we're going to call these types of lines rays. Okay, so those are the rays. Now the next question you need to ask yourself is, how do you find the gradient of each ray? Well, it's simple. You're going to take the total cost divided by X. So that's how you find the gradient, right? So the fact is that the steeper the ray, okay, you're going to get a larger gradient. And just a gentle reminder, to find the gradient, you simply take the total cost divided by the quantity of X produced. So when you have a larger gradient, this simply means you have a larger average cost, because TC over X is your average cost. So going the other way around, if you have a flatter ray, what it means is that you're going to have a smaller gradient. Okay, because the result of TC divided by X is lesser. So when you got a smaller TC over X, what it simply means is that you have a smaller average cost curve. So that is how you find out the average cost. And that is how you're going to find out that AC0 is going to be bigger than AC1. And AC1 is going to be bigger than AC2. So you see, it's actually pretty easy, if you were to think it this way, to derive your average cost curves from now. Okay, so I'm going to show you an example. I'm going to show you how to derive one average cost curve from a regular short run total cost curve. So I'm going to derive this AC right now. I'm going to offer you three very simple steps. First, you separate. I'm going to talk about that later. And then you find out what are the rays, and then you plot the graph. So talking about the race, I want to find the minimum average cost first. So what is a minimum average cost? Think about it. Well, it's simple. It is simply the flattest ray that starts from the origin to the short run total cost, or the long run total cost if you're using it. You're going to notice that I'm drawing two sets of axes, and the reason is because I need my short run total cost to derive the short run average cost. So that's why there's going to be two graphs. Okay, so that's my short run total cost, and the first step is to identify where is the minimum AC. So to find the flattest ray, I simply put my ruler up here, and I'm going to start traveling down until I reach the flattest ray that I can find, which is here. So that means at this quantity of X produced, let's call it XM, my average cost is the minimum. Okay, so that is my minimum AC. The next step will be to determine what the rest of the average cost curve should look like. So I'm going to separate the entire short run total cost into several pieces, and I'm going to start drawing rays to all these different regions over here. Okay, so the last one looks a little bit, it looks like the same as the second one. So you look at all these rays, it starts to get flatter in the beginning, right? So you see the first ray is steep, and then it starts to become flatter, and towards the right side, it becomes steeper. What that means is when you produce lesser quantities of X, okay, your average cost is going to be very high, it becomes very low, and then it starts to go up again. So that is why your average cost curve looks like this U shape that you see over here. Yes, it is that easy to derive your average cost curves. So now we're going to move on to the marginal cost curve, and you know that the marginal cost curve is actually your change in total cost divided by the change in X. So how do you use a total cost curve to derive the MC? Well, it's actually very simple. What you need to do is to differentiate the curve equation. Alright, so you're going to differentiate the curve equation. Why? Well, that's because when you differentiate the curve, you are trying to find out what is the rate of change. So how do you find out the rate of change? Well, it is simply the gradient of the curve, because when you differentiate the curve, you're going to get this gradient, right? So that is how you're going to find the change in the total cost divided by the change in X. So graphically, how are you going to find out what is the gradient of this curve at that particular point of X? How do you find the gradient? Well, according to basic maths, what you need to do is to draw a tangent across that point. So you're going to need to draw tangents across the total cost curves in order to find your marginal cost. So drawing these marginal cost curves is going to be slightly more straightforward than the average cost curves. Okay, so I'm going to begin by showing you the short run total cost curves and how we're going to draw the tangents. So now the first thing we're going to do is we're going to separate this into several portions. So you're trying to find the marginal cost for x0, x1 as well as x2. So you draw dotted lines up to the total cost curve and you draw a tangent. So there you have it, you've got MC0, MC1 and MC2. So that is simply how you find the amount of your marginal cost, alright? You're finding the magnitude of your marginal cost. So now, you know that when the tangent is steeper, this means that it has a larger gradient. And the gradient of the curve is simply going to be the change in the total cost divided by the change in X, right? So when this is larger, it simply means that your marginal cost is larger, right? The change in cost per unit is larger. If the tangent is going to be flatter, then you're going to have a smaller gradient, okay? So the smaller gradient will also mean a smaller marginal cost. So that's how you're going to compare the magnitudes of marginal cost at x0, x1, and x2. So I'm going to extend this graph to a marginal cost curve graph below, and you're going to notice that it is also in a U shape. So that is my marginal cost curve. But here's the thing. If I'm going to compare this to my average cost, how would I know which cost is higher or larger, smaller or lower for different quantities of X produced? How am I going to do that? So that brings me to the next point, which is how are we going to put together the average cost as well as the marginal cost? So that will be the next branch of this mind map. We're going to be putting together your average cost and your marginal cost with the help of your total cost curve. Doing this is going to take you only 3 very simple steps. Now, the first step that you always want to do is to find your minimum average cost. The second step would be to draw the average cost curve, and the third step would be to draw the marginal cost curve. So you're going to end up with something that looks like this. That's your marginal cost and your average cost joined together. Now the point where they actually intersect is actually where the minimum average cost is. So another conclusion that you're going to find is that the minimum average cost is when the average cost and the marginal cost is going to be the same. I'm going to explain my case in just a little while. So the setup is pretty easy. You're going to need two sets of axes. Okay, so on the top is going to be your total cost, and the bottom is going to be your average cost and marginal cost. So the top is going to be my short run total cost, and I'm now going to start by finding my minimum average cost. Alright, we went through this earlier on how to find the minimum average cost. So that's the point. That is the amount of x, okay, xm for example, where my average cost is minimized. Okay, so I've got 1 point right there, and the next step would be to simply draw the average cost curve. Now, we know that the average cost curve is going to be a U-shape like how you see over here. Now, here comes the part where you put in the marginal cost curve, okay? So the marginal cost curve is going to look like this, okay? There's the curve in blue. Now, why is it shaped this way? Why is it that on the left side of the minimum average cost, the average cost is higher than the marginal cost? And why is it that on the right side of the minimum average cost, the marginal cost is higher than the average cost? To find the answer, you need to compare rays and tangents. Let's take a look at the left side of the minimum AC. So this is a ray, and this is a tangent. Which one is steeper? Obviously, the ray is steeper than the tangent. And because the ray is steeper than the tangent, that is why your average cost will always be higher than your marginal cost. And it is only after you reach the right hand side of the minimum average cost, okay, you're going to check out that this ray is going to be flatter than this tangent over here. So the tangent is actually steeper than the ray. That is why on the right hand side of minimum AC, your MC will be higher than your average cost. So that is a simple reasoning as to why the average cost and marginal cost, when combined together, looks like this. And the points where they intersect is where your marginal cost is equals to your average cost. Why is that so? Well, that's because at XM, you will notice that the short run total cost actually shares the same tangent and the same ray. Try it out yourself. You brought the ruler down to its lowest point so that you would touch the short run total cost curve at its lowest, right? So you drew a line across, and just nice, it is also a tangent to the short run total cost curve. And that is why at that point your MC is equals to your AC. So one of the mysteries in the universe has been solved. Okay, now you're going to notice that this portion is where the firm is experiencing increasing returns. In this case, it is short run, so it is increasing returns to factor, and on the right hand side, that's going to be decreasing returns to factor. Okay, so that's another interpretation of what's happening over here. So at this point, I encourage that you pause the video and go practice deriving the average cost curves and the marginal cost curves by yourself. If you've already done that, let's level up. Let's talk about drawing both the average cost curves and the marginal cost curves for the long run as well as the short run. So why are we doing this? We're doing this because we want to compare what is the difference between the long run and the short run in terms of your average cost as well as your marginal cost curve. Now, one of the things that you should take note is that the short run cost is always higher than the long run cost, especially for your average cost. And this can be seen in your ISO cost and ISO quant video. Alright, so this is a very important point for you to remember. So how are we going to do this? So we are going to need the long run total cost as well as the short run total cost combined together in the same graph. And we're going to draw all the short run, long run, average, and marginal costs in this particular order. Now, the first curve you're going to draw is the long run average cost curve. The second one will be the long run marginal cost. The third one will be the short run average cost. And then the fourth one is going to be your short run marginal cost curve. So that is the order that I recommend. Now, for the short run average cost, you're going to notice that there is going to be a point where it is equals to the long run average cost curve. So you're going to need to find the intersection. And it happens to be above the x, whereby your long run total cost curve equals to your short run total cost curve. That is because at that point, both total cost curves are sharing the same ray. Okay, and next you're going to have to find out where your minimum SRAC is. So let's talk about the SRMC. What you should be concerned about is intersections. Now, it's going to be intersecting at 2 points. First, the minimum SRAC, well that's obvious, you have just derived this just now. And there is also a point where it intersects the LRMC. Well, the reason for this is actually pretty simple, because there will be a level of X where the long run total cost will be equals to the short run total cost. And that is because they share the same tangent. Okay, so that is why you're going to have an intersection between the LRMC and the SRMC. So let's put all these words into graphics so that you can understand what was going on. Okay, I'm going to be drawing again two sets of axes because I'm going to need both the total cost curves to derive my average cost and my marginal cost curves. Okay, so I'm going to start by filling up my total cost curves. So here is my long run total cost in blue. And then I'm going to have my short run total cost in red. There will always be an intersection there. Why? Okay, think about your isocost and isoquant video. Think about your long run, short run video. Why is there an intersection? Well, that's because there will be a point where your long run expansion path meets your short run expansion path. So please remember that. So as discussed earlier, the first curve I'm going to draw is my long run average cost curve. So I find the minimum for the long run average cost curve and I identified it to be there. Okay, so that's the minimum. And then I know that the average cost curve is always going to be a U-shape given this type of total cost curve. So I found my LRAC. Very simple. Next thing I need to do is to simply add in my LRMC. Okay, so I've got all the curves for the long run. Now we just got to settle the short run. Now the first thing we need to draw is the SRAC. So let's find out where the SRAC meets the LRAC. Okay, it is the point over here where the long run total cost equals to the short run total cost, and let's find out whether it shares the same ray. Well, it obviously does. I just drew it, right? So that is where the rays point to both the SRTC as well as the LRTC. So I'm going to extend a dotted line all the way down. I know that there's going to be an intersection right there. Okay. Now the next thing I'm going to need to do is to find my minimum short run average cost. Okay, so that's my flattest ray. I'm going to bring it down. I know that the minimum SRAC has to be below this point because if it's not, then it's not much of a minimum, isn't it? And it has to be above this point because the short run average cost curve will always be higher than the long run average cost curve. This is what we saw in the isocost isoquant video. So these 2 points are all I need to draw my average cost curve. It's going to be a U shape, so just let me carefully draw it nicely into a nice U shape just like this. Okay, and there we have it. I have my short run average cost curve. Alright, just one more curve to go. Just my short run marginal cost curve and we're done. Okay, so let's take a look at the intersections. We're going to need to find 1, 2 intersections. So the first intersection is of course over here. That is the minimum short run average cost curve. That's the basics. And next we have to find out where the long run marginal cost meets the short run marginal cost. And that point is going to be over here. Well, the reason is because at this quantity of X, the long run total cost as well as the short run total cost is going to share the same tangent. So when the tangent is the same, that means the gradients of both of it are the same. That means the marginal cost is going to be the same. So you got 2 points. What I'm going to do is I'm going to match these 2 points together. Okay, and then I'm just going to draw this upward sloping curve over here. And there we have it. We have our short run marginal cost. Okay, so you have successfully drawn all the 4 different kinds of cost curves that we need. And I suggest that you pause this video right now to go and practice this because you might actually come out with different results for how your depending on how your total cost curves are being drawn. I'm not going to spend the last few minutes of this video to actually show you what are the different types of results that you can see. I'm going to begin with one single long run average cost curve. So that's my long run average cost curve over there. So what we just seen previously is this green in color short run average cost. So that's SRAC1, that's the minimum average cost. Okay, you can also see sometimes that the short run average cost can look like this as well. That's the minimum average cost. So well, this looks like a pair of boots, but we'll make it look not wrong in a little while. Okay, so the short run average cost curve can also look like that, where the minimum AC for both the short run and the long run is the same point. Okay, So this depends on how you draw your long run total cost as well as your short run total cost and how they intersect one another. Okay, so let's add the MC in. The MC for the long run is very simple. It's just this black marginal cost curve over here. You will start to notice a very simple rule. Okay, then the rule is this: the point where the SRAC meets the LRAC is also where the LRMC will meet the SRMC. So I'm going to show that by drawing a vertical line down to the LRMC, and that is also where the point, that is also a point where my SRMC will meet my LRMC. So that is how I got my SRMC1. Moving on to the second average cost curve, I'm going to draw the marginal cost for it. Okay, so this point over here where the SRAC meets the LRAC is also that particular intersection where my LRMC will meet my SRMC. So I'm going to draw my SRMC that looks like this. It's going to cut through the minimum AC and it's going to cut through the LRMC at that particular point. So for the middle average cost curve, it's going to be very simple. The marginal cost curve simply cuts through the middle upwards like that. Okay, so that's the SRMC number 3. So the conclusion is this. Okay, at a point where X, okay, has the long run total cost curve equals to the short run total cost curve, okay, I can safely say that my long run MC will equal to my short run MC and my long run AC will equal to my short run AC. This is always true. Okay, I suggest that you stop the video and you go practice by yourself and you will notice that this results is always consistent. Okay, we have passed the half an hour mark and I'm sure some of you might be pretty tired, so I'm just going to stop here and give you a little bit of a preview of what's happening next. So in the next video, we'll be talking about the dynamics of the AC and MC, and we'll be going through some of the bonus materials as well as the special cases. So this video and the next video is going to be very important for you, so I suggest you rewatch this, okay, so that you'll be ready for market structures. So I want to thank you for studying with Quickienomics. It's been great having you around. We'll see you in the next video.